Hello everyone, welcome to today's TechGoodReads. TechGoodReads give you good thing to read and to listen. Today, I will talk about a problem happening in our company recently. Is service latency caused by TCP Stack. For our service, we have a cross-region calls. It means a service from one AWS region call another AWS region services and get response. For such a cross-region calls, the latency increased recently, and with some deep dive, we found that the problem is caused by the networking change. Before understand what happened, I need to have some concepts of the TCP. First concept is the TCP three-way handshake. In the establishment of a TCP connection between a client and a server, a TCP three-way handshake process is performed. It means three-way handshake. There are three packages between the client and server. When we want to do such a handshake, usually the clients need to send a sequence and then server send back a ACK. That's two messages. If server send one sequence request, client send a ACK, then that's another two messages. But for the three-way handshake, it's just to combine the server's response with the ACK to the client's sequence and also send the server's sequence. In this way, three packages can help establishment a connection. For the TCP, when it sends data, it will split a big packages into several segments. It's not send a segment and then wait for the response, but it send the first segment and then send a second segment. It uses a sliding window. This sliding window will define how many segments can send and then wait for the next response. We can see the right side of the picture when the first segment is sent from the server to the clients, and then the server sends the second segment. When the client gets the first segment, it will respond with an ACK. If there's some networking problem and the segment 2 is lost, then segment 3 is sent to the client. The client will check the sequence number and find is the segment 1 received and currently received segment 3. So the client will send to the server to ACK 1. And if another segment 4 is received, client also send ACK 1. When the server received such a duplicated ACK 1, server will know that the client lost the package for the SACK 2, and then it will resend the SACK 2, and also with the following all the packages. So we can see that for this TCP normal mode, losing one package will need to retransmit following packages, but that's not sufficient. TCP Stack is introduced to resolve a bow issue. From this picture, when the server sends to the client with the segment 2 and is lost, the client receives the SAG 3 and it will send to the server with ACK 1 and SAG 3. In this way, when the server receives these messages, it will know that segment 2 is lost, so it just need to resend the segment 2. In this way, it will help reduce the packages on the network. So if your network is very high bandwidth and there's less packet loss, using the TCP Stack should be reduce the packages sent on the network. It will improve the networking efficiency. For our server's problem, it has some characteristics. For the VIP, it will use backend connections. It means many clients connect to the VIP with different TCPs, but the VIP will only use one TCP to the real servers behind the VIP. Another special configuration is that when the SACK is enabled on the VIP, the resend time is lower than the Euro TCP. This configuration caused the issue. As I said, for the cross-region calls, the VIP received many requests from the clients that from different regions. Such traffic are expected to have a higher latency. For the TCP, it will cause too many ACK. When too many ACK reached VIP, and it will cause congested. Due to this reason, each package will have a higher round-trip time. Because this RTT is high, so the TCP will adjust a congestion window to a very small one. This will cause the latency increase. I hope you have some basic idea of TCP, how it causes the latency. Thank you for listening. See you next time.